My name is Morten Dalsmo. I'm Executive Vice President in Sintef and Head of Sintef Digital. We are working with applied research and innovation in digital technologies, in health and social sciences. And we are really engaged in AI as well, and that is one of our areas of strategic priorities. In this session, we will look at the opportunities and challenges related to AI. In the previous session, we talked about regulation, and I think we need to see a balance between innovation and regulation. And in this session, we will, which is called Artificial Intelligence, What's Next? We will really look into the opportunities of AI, but also, of course, the challenges. And we have a lot of really good speakers, so you can really look forward to this session. We have Anders Hansen, professor at Cambridge University and University of Oslo. We have Ulrik Vestergaard Knudsen, Deputy Secretary General of OECD. We have my colleague, Signe Riemer-Sørensen, Research Manager, Sintef Digital. We have David Cameron, Head of dScience Partnerprogram, University of Oslo. We have Ingrid, Professor, University of Oslo. And finally, we have Amu Loutfi, Professor, School of Science and Technology at Örebro University. So, the first speaker is Anders Hansen. Enjoy.
Great. Thank you. Thanks a lot, and thanks a lot for the invitation. Great to be here. Awesome event. Really enjoy it. I'm going to start by asking the question, how do you know when you're right? And this is intimately related to the issue of hallucinations and the limits of trustworthy AI, which I'm going to discuss. So, we all want trustworthy AI, but the Achilles heel of trustworthy AI are the hallucinations. And I don't need to spend a lot of time showing you the chatbot's hallucinations. It was actually done very nicely in one of the very nice former talks. You have played with it yourself. And it can very eloquently put out complete nonsense with great confidence. And just to illustrate this, I want to show you this headline here. This is from IEEE Spectrum. IEEE Spectrum is the flagship magazine of IEEE. IEEE is the largest engineering organization in the world. And we read, hallucinations could blunt ChatGPT's success. OpenAI says the problem is solvable. Jan LeCun says, well, we'll see. So what happened with ChatGPT was essentially that the phenomenon of hallucinations essentially came in literally in the living rooms of the general population. But hallucinations in AI is widespread, universal, and very well known in the community way before the ChatGPT. So AI is used universally now throughout the sciences. And I want to show you this. It's not a great projector, but I'm going to try to convey what it tries to do. If you, for example, are in an MRI scanner, it takes a lot of time, and it's very costly. And we would like to reduce the scanning time. AI can do that. Here's an example from the Facebook Fast MRI Challenge. Here is a 4 times speed up with AI, but at the cost of a hallucination. You see this one here? This detail here does not belong in the patient's brain at all, and it's very hard for the radiologist to determine if this is physical or not. And it will fool the radiologist. This is extremely dangerous. So hallucinations in AI is not just the chatbots. I'm not going to read all of this to you. I just wanted to show that this is a general concern in the sciences, and we've known this for a long time. Here is one from the Fast MRI Challenges. Such hallucinatory features are not acceptable. And here's one from Nature Methods. The most serious issue when applying deep learning for discovery is that of hallucination. These hallucinations are deceptive artifacts that can appear highly plausible in the absence of contradictory information. So the problem now is, how do you know when you're right? And how should the AI know when it's right? Big problem is really, why cannot AI detect when it hallucinates? And this is intimately connected to explainable AI. We want AI to explain to us why it came up with that conclusion, right? It's extremely important in medicine, for example. That's why I want to show you this headline here. For those who are interested, there are two big outlets in medicine. One is the New England Journal of Medicine, and the other one is The Lancet. And here is a headline which is quite descriptive regarding AI and explainable AI in medicine. The false hope of current approaches to explainable artificial intelligence in healthcare. And I want to read from the intro here. It has been argued that explainable AI will engender trust with the healthcare workforce, provide transparency into the AI decision-making process, and potentially mitigate various kinds of bias. In this viewpoint, we argue that this argument represents a false hope for explainable AI and that current explainability methods are unlikely to achieve these goals for patient-level decision support. It is quite a descriptive paper. I highly recommend it. The issue is this: how do we actually make explainable AI? And the reason why it's so important is that it also becomes a legal issue. So this is pointed out in this excellent article. The General Data Protection Regulation has been mentioned before, and there's a part of it which is extremely important. In the EU state that people have the right to meaningful information about the logic behind automated decision using their data. So, can we explain that in a meaningful or logical way? That's a very delicate issue. Now, can we make explainable AI? I'm going to show you an example to show the delicate issue. So, modern AI is incredible at doing pattern recognition. You can train a neural network to figure out what is in an image. And here is a case where the AI has been trained and it can tell you what is in the image. In this case here, it says it's a dog. Fantastic. Very good. The issue is that you can't just call up the AI and say, please tell me, how did you figure out that this is a dog? You can't do that. But what you can do is that you can provide these kinds of saliency maps. And these are the pixels in the image that were crucial for the decision process of the AI to tell you that this is a dog. And when you look at it, it's striking. I mean, you can see the snout here. You can see the contours of the eyes. You can see the contours of the pointy ears, even the tail here. And I would say, yes, I could totally understand that these are features that would make it say it's a dog, right? And everything is awesome until this happens. So now somebody took an image which is slightly different from that. You can't see the difference with the human eye. And now the explanation is this. I'm a little disappointed by the authors who did this. It would have been much more fun if it said, I'm a cat. In fact, I could have put anything in here. I could have drawn an image of a cat. I could have drawn an image of Mickey Mouse. And this suggests how extremely delicate it is with explainable AI. In fact, we're not doing very well. All right. And this brings us to the delicate issue of the limits of AI, which I'm going to talk about. Now, to give you a little bit of perspective, I want to show you this article here from IEEE Spectrum. So this is when they summarized all they have talked about in AI in 2021. And I want to read from the intro. 2021 was the year in which the wonders of artificial intelligence stopped being a story, which is not to say that IEEE Spectrum didn't cover AI. We covered the heck out of it. But we all know that deep learning can do wondrous things and it's being rapidly incorporated into many industries. That's yesterday's news. Many of this year's top articles grapple with the limits of deep learning, today's dominant strand of AI, and spotlighted researchers seeking new paths. So what we also see now is the pendulum in the research world is also slightly changing its direction. In the beginning, it was all about we need to check what can we do with AI. Completely agree, awesome. But we need to understand the limits. And this brings us to the very delicate debate about the foundations of AI. And if you have not seen this before, I highly recommend that you Google it, because it was a feisty debate when Google's Ali Rahimi on the front stage of NeurIPS, when he won the Test of Time Award, likened modern machine learning and AI to alchemy. That did not go down well with everybody, as you can see, but it is a very important thing that we can learn. You can agree with Rahimi or you can disagree with him. But the important thing is that we can learn from the alchemists. So what did the alchemists want to do? They wanted to create gold. How would they do that? Well, they would buy a pot, add a little bit of green, a little bit of yellow, stir, no gold. Aha, red is what's missing. A little bit of red, stir again, no gold. You can continue that over and over again to the infinite, and you will never find gold. But important thing is that that kind of research methodology of just trial and error will never be able to understand its limitations. You need to do something fundamentally different to understand that you cannot create gold. And we are now in a very similar situation to what actually happened in mathematics in the beginning of the 20th century. The word crisis was used. And the reason why it was a crisis was that one understood that we didn't have the foundations of mathematics and not the foundations of computations either. So this was led by David Hilbert, who was at the time one of the most, if not the most, prominent mathematician around. And this program, now with legends like Turing, Gödel, and Russell, had an enormous impact. But what happened was that Gödel and Turing turned this completely upside down. Gödel showed that there are mathematical statements that you cannot prove or disprove. That sounds completely bizarre. And Turing showed that there are basic computational problems that cannot be solved by a computer. That alone shows that there must be inherent limitations of AI if it's going to be executed on a computer. The problem is which? And now, this prompted Steve Smale to ask that question. Steve Smale was, or is, he's 93, still around, one of the most influential American mathematicians of the 20th and also 21st century. And he created a list of big mathematical problems for the 21st century. The last one on that list, number 18, is what are the limits of AI? And of course, this is not a problem for which you can solve and have sort of 2 lines under it and say, I've done it. This is a call for a program. And that's what we're going to talk about now. All right. Because I want to ask the very basic question, can we create AI that checks if it itself is correct? In scientific computing, this is referred to as an exit flag. A flag that says, now you're good. A flag that says, no, 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 this is wrong. You can't trust this, right? We want to have a flag that says, you're good, now you're hallucinating. The question is, can you do it? Right? And I want to show you that this is actually completely mainstream in scientific computing that may have nothing to do with AI. You see this table, you say, what on earth is he trying to say? This is an exit flag table of a commercial software used in scientific computing called MATLAB, and this is for their optimization routines. We don't need to understand the details. The point here is that modern software typically has these types of failure parameters that can say, now you shouldn't trust me. But I also have a parameter that says, now you can trust me. And that exit flag is something that we would like to be able to compute. And now I'm going to show you a mathematical theorem. And I have made it so that it's readable for a general audience. And I'm going to explain to you what it says. All right? There are basic problems for which there exists a neural network. When I say neural network, think AI. Neural networks are the building blocks of modern AI. There are basic problems for which there exists AI that doesn't hallucinate, but no algorithm can compute that AI. That means that for these problems, any attempts of creating an AI for them is going to give you an AI that hallucinates. That's not the paradox. Now the paradox happens. Any attempt of trying to check is going to fail. It is impossible to check whether any AI hallucinates on these problems. In layman terms, we cannot in general check whether AI hallucinates or not. And if I just told you this, you would think this guy is completely bonkers. But given the history of Gödel and Turing, he may not be completely crazy. And in fact, this really is research which is in the footsteps of these giants. Of course, there's much more modern mathematical techniques now, but this is essential. And now comes the corollary. Corollary is in mathematics something that follows from a theorem. And here it is. Trustworthy AI must be able to say, I don't know. There's no theoretical limitation suggesting that you cannot have AI that says, I don't know. You will not be able to have AI in general that says, okay, now I'm hallucinating, but now I know what I'm doing, and I don't know what I'm doing. You will have to have something that says, I don't know. And this is the problem. We don't know how to create AI that says, I don't know. Humans can say, I don't know, which is good. How do you make the AI say, I don't know? And I'm going to show you a very simple example, all right? So AI is used in a lot of different areas. Medicine, for example. This is for cancer detection. This is skin cancer detection. You train an AI to look at images of a mole, and you want to know if this is benign or malignant. And in this case here, it is very confident that it's benign. Awesome. Great. But I can add a little bit of a noise to that image, and then suddenly it is now very confident that it is malignant. Now, these two things cannot be true at the same time. One of them is wrong. It's disturbing that it does change its mind with just this tiny little perturbation. Never mind that. It is very confident here, and it's very confident here. It would have been much, much better if it was very confident here, and then it said, look, I'm changing my mind, but I really don't know what I'm doing. That would be trust, right? Back that. So, now, the foundation stuff becomes political. I want to show you a headline. This is from a couple of years ago, so this refers to a minister in the previous administration. I just want to highlight that. It says, I'm going to translate from Norwegian, artificial intelligence may improve public sector management, in this case here, Nav, and that's certainly a very good debate that we should have. But right now, I'm interested in the legality of the issue. Could, for example, Nav have an AI that would determine if I should have childcare support, yes or no, with no interference of a human, given the lack of trust and lack of explainability? Would that be legal within the current framework? Would it be legal within the EU AI Act? And that brings us to, and we heard a lot of great talks about this, the EU AI Act. And I want to highlight that the European Commission did a very thorough and very good job doing a lot of research and reading the literature on this and providing technical reports that eventually ended up with this outline for legal AI that was the starting point for the process. And I want to highlight this. In the light of the recent advances in artificial intelligence, the serious negative consequences of its use for EU citizens and organizations have led to multiple initiatives from the European Commission to set up the principles of a trustworthy and secure AI. Among the identified requirements, the concepts of robustness and explainability of AI have emerged as key elements. Absolutely. And we learned that trust is the must, and that we should trust, Europeans can trust what AI has to offer. The problem is, what do we actually mean by trust and explainability? particularly given that that is not particularly easy to create. And here's an example that I want to show you. There's a list, we've heard about this earlier today in one of the excellent talks, that there's a list of problems that are high risk. And on that, we have one which says law enforcement. That makes things very delicate. And that's why I want to show you the COMPASS algorithm. The Correctional Offender Management Profiling for Alternative Sanctions COMPASS algorithm. This is an algorithm which is used in the United States. It's legal. It is there to predict if an offender will be a repeated offender. The way it works is that the AI takes the file of the offender and it gives you a score. High score means that you're likely to be a repeated offender. A low score means that you are unlikely to be a repeated offender. And this is used for sentencing and for parole applications. There has been points made that this is a biased algorithm towards people of different race. That's a serious issue. I'm not going to discuss that right now. I'm asking about the legality of it. Would the COMPASS algorithm, which is legal in the US, be legal in the EU right now with the legal framework we have? Would it be illegal under the EU AI Act? And a third question, I think, which is also important, that is, should it be illegal? Okay, I am running out of time, but I do want to add one more thing before we end. I have talked a lot about trust in AI, but I also want to mention the delicate issue of trust in researchers in AI. Because research now in AI is done a lot in industry, awesome. It's also done in academia. But research done in industry comes with also an obligation. And if you have not heard about this case here, you should Google it. Timnit Gebru is somebody that everybody should know who is. Timnit Gebru is an Eritrean-born American lady. Here she is. Very well-respected researcher in her field. She was hired by Google, and she was also fired by Google. And what she did was that she wrote a paper suggesting that the large language models that Google were using could potentially have bias in them. The paper went through all the different types of routines that you have to do before it's sort of put in the public domain. And at the end, Google said, you can't publish that paper, or if you do it, we will fire you. The rest is history. You should Google. There's a long story here. I just mentioned this as the headline from New York Times. There's many stories about it. Gebru was fired from Google, and the fact that big tech companies fires researchers when they provide criticism is a very serious precedence. I want to mention it. To be on the record, I am paid by University of Cambridge, I am paid by the University of Oslo, I'm paid by the Royal Society. None of these institutions can fire me regardless of what I say on this stage or any papers that I write. As I suggested, please do Google the Timnit Gebru case. And also, there are other cases as well that New York Times has reported on firings of other researchers. Anyway, I'm going to wrap up. And if you're interested in the mathematical framework for this, I hope you are, you can check out this paper here. If you're interested in a slightly sort of layman version of that, there is an article in IEEE Spectrum about these phenomena and issues. And I'm simply going to end with some completely shameless self-promotion and say that there's also a book. Some of this is in the book, not all of it, but I hope you enjoy reading it. And with that, I thank you very much for your attention.
Thank you very much, Anders. A main takeaway from me there was that AI simply doesn't know when it's hallucinating. I'd say that goes also for a lot of keynote speakers, perhaps even this one. I wish there was a method to find out. I'll try not to hallucinate. Thank you so much for the invitation to join this very interesting and promising Nordic initiative. Maybe really this intervention should have been put a little bit earlier in the day, because I am going to try to do a little bit of an overview of the regulatory global stage, but of course with a focus on what the OECD does, and in that sense, like you, Anders, there'll be a little bit of self-promotion in it, but that's the price of having us here. You know, it's almost too much of a cliche to start any keynote like this, but I do think that it is perhaps more true now than ever that rapid technological transformation is heralding a brand new era of boundless opportunities. I think that is more true than perhaps ever, at least in my lifetime. It's also a time of, if not grave, then certainly significant risks. Some are talking about even existential threats to humanity. That's maybe taking it a bit far, but this is all something that is specifically related not just to AI, but perhaps specifically to generative AI. Now, my organization, the OECD, was founded over 60 years ago on a simple yet very powerful premise that international cooperation is essential for economic growth and social prosperity, but also essential for solving international cross-border problems like AI. In the decades since, we have leveraged evidence-based policy expertise, mutual exchange, data, and analysis to keep ahead of such global cross-border challenges. And this is also why we have increasingly dedicated our attention to AI over the last 5 or 10 years. Artificial intelligence is already now demonstrating its absolutely revolutionary potential for productivity, for healthcare, for education, as well as for accelerating, and this is important, scientific discovery. I am also personally convinced it can help us to address global challenges like climate change and poverty. AI is evolving in dramatic and increasingly pronounced ways. For example, preliminary findings on the impact of generative AI on productivity suggests a real paradigm shift, including for higher income jobs. I joked about it earlier, but it's true. It's not surprising, perhaps, when you consider that ChatGPT-4 already passed the uniform bar exam and actually was placed in the 90th percentile. But AI can also present challenges and risks beyond labor markets, which are, as we talked about earlier today, still quite uncertain. These include perpetuating societal biases. I want to highlight gender biases, but also implications for privacy and security. Generative AI specifically increases risks from the creation and spreading of disinformation and manipulated content at scale. It also raises challenges for copyright and other intellectual property rights. It was also covered this morning, mainly because generative AI is often trained on copyrighted materials. I don't think it's over-dramatizing to say that with generative AI, humanity is facing a watershed moment, or, if you go to the movies, perhaps an Oppenheimer moment, if you will. Our well-being, our economic prosperity, and our very identity as humans even, will be affected by the collective action we take today. We need a global effort for the governance, safe development, and deployment of AI, aligned, and that's important, with human rights and democracy and democratic values. And I think also it's fair to commend the Nordics for having been early movers on this. With the declaration from the Nordic Council of Ministers on AI in the Nordic-Baltic region as far back as 2018, this focused on skills, on access to data, on developing guidelines, on principles, and also standards for the application of AI. But I also have to warn you that the world is catching up with the Nordics. The G7 leaders, in partnership with my organization, the OECD, set up the Hiroshima AI process only in May this year to plot out a common course of action around generative AI. I was with G7 ministers in their meeting on Monday in Kyoto when they almost agreed on a set of guiding principles. Then they are now putting that out for multi-stakeholder consultation, and they will move on then to a code of conduct. Things are happening quite quickly. A little bit lower speed at the G20, where leaders made a global call with their joint declaration for discussions on international governance for AI, but at a level of much, much less specificity. Also, the UN is, wouldn't say waking up, but I was in New York for the UN General Assembly Ministerial Week a couple of weeks ago, where Amandeep Gill, the UN Secretary General's Special Envoy for Tech, opened the first advisory board for high-level advisory board on AI. What this goes to show is that we're going to need regulation on AI at different levels. What we can agree to at the UN, at the G20, will not be as specific as what we can agree to at the OECD or at G7 or even among the Nordics. The more like-mindedness, perhaps the bigger the level of ambition for agreeing to principles or guidelines. But I will brag a little bit and say that the OECD is at the heart of all of these discussions, be that in the UN or the G7 or the G20. And we have actually been developing AI policy making ever since the landmark 2019 OECD recommendations on AI. That was the very, very first intergovernmental standard on AI. The principle articulated there were taken up by the G20, and that's diplomatic language for copy-paste. And they have influenced the emerging AI policy frameworks ever since. Very, very briefly, we designed them as flexible, future-proof, and value-based, and they promote 5 foundational principles if you don't know them. 1, the pursuit of beneficial outcomes for people and planet. 2, human-centric values and fairness. 3, transparency and explainability, and Anders, please don't ask me to explain what explainability means. 4, robustness, security, and safety, and 5, accountability. The AI recommendation also provides guidance on AI systems and policies. As we're nearing now the 5-year mark from its adoption, the OECD is now in the process of reviewing the implementation of the recommendation, both to take stock of what governments are doing and to understand how the principles apply in the context of these new developments, not least generative AI, of course. The review is already underway as we speak, and we will aim to complete it next year in 2024. We've also taken steps to help move the principles into practice through the OECD AI Policy Observatory and the OECD Working Party on AI Governance. We gather the key evidence on AI through the OECD framework for the classification of AI systems, the catalog of tools and metrics, and the AI incidence monitor. That is, by the way, where we track also important hallucinations to see if we can learn some lessons from that. Now, all of these work streams have already had a direct effect on policy and standard developments around the world, including in the US and also in the EU. OECD standards and definitions are informing the EU AI Act, as Sophus mentioned so graciously earlier. On generative AI, we are also trying to stay ahead of the curve. It's not easy. It's not easy given the speed of developments, but we're trying to research and assess its implications. We've just released a report, I really highly recommend it, mapping initial policy considerations for generative artificial intelligence, and we're also going to focus on this in our upcoming 2024 Digital Economic Outlook. At the same time, we're trying to grow the evidence base, but of course, with technology developing so quickly, we need collective action, we need global, ambitious decisions now to ensure that this technology will be safe and beneficial to societies. And as I think it should be clear by now, also from this morning's discussions, there are at this point many, many more questions than there are answers. Do we need hard rules, for example, about the design of safe AI systems? The EU answer seems to be yes. Japan, US, UK, perhaps a less hard answer. How do we marshal the innovation, the governance, and the regulation of AI? How do we prepare society for this transition? We haven't talked so much about that today. And how do we make sure that powerful technologies don't rest solely in the hands of a few? And when I say few, I don't mean just countries. I also mean in the hands of a few companies, perhaps just as importantly. But perhaps the main question for me, we always focus a lot about risks and threats. And I think in this room, we all agree, also from the networking conversations, that we should perhaps not get totally bound up in the discussions about the risks and the threats. We should be the ones also promoting the opportunities. And that is perhaps the most important thing to me. How do we address this in a regulatory way where we do not compromise the boundless opportunities for people and planet? I think we have an obligation, us collectively, also to communicate that to a wider audience. I don't know the answers to all the questions I just raised, but I do know one thing, I think. I think the decisions we make in response to these questions do require international cooperation. They do require international coordination. They require multilateralism. As I said, we work closely with the G7, the G20, and international partners in the UN, and there is some good news stemming out from these processes. But I also think we're going to need different layers of regulation, as I also said this morning. China has a different approach to this than democracies. Advanced democracies have a different set of needs than countries perhaps in sub-Saharan Africa, but we need to make sure that we don't abandon anyone in this regulatory process. One more thing I'm pretty certain of is that we cannot advance in these endeavors without effective multi-stakeholder engagement. Another reason, I think, why fora like this one is so important. Multi-stakeholder participation has always been our approach at the OECD to policy development. Also in the field of AI, we have, for example, our One AI expert group, where we have over 400 international experts. They come from the civil servants, they come from governments, they come from industry, they come from academia, some are technical experts. And the same goes for our recently launched the OECD Global Forum on Technology, currently building its outreach and engagement. I firmly believe that it is only with the very active involvement of business and industry and academia and civil society that we can develop and implement policies that really work in a credible way for the whole of society. And I'm really delighted to have witnessed over the last, 20 hours or so, so much passion, so much healthy engagement from the Nordic countries. So to conclude, please count on me personally to take your reflections and takeaways back to Paris and OECD and the other fora where we try to help. And count on my organization, the OECD, to keep bringing the evidence and instruments to shape responsible AI forward, also to provide the forum, the resources, and the convening power to advance these multilateral deliberations. Thank you very much.
My name is Signe Riemer-Sørensen. I work at Sintef as researcher for analytics and AI. And I'm going to talk about hybrid AI for industrial systems. This summer, we've all seen the effects of climate change. We've had heat waves in southern Europe. We've had heavy rainfalls and floods in Norway. And in the future, we'll have to adapt to these climate changes as well as lower our emissions so that we don't end up with a climate runaway. The majority of emission comes from industry. And AI can help us reduce this emission, but only if we become much better at using it for industrial physical systems. And this is only possible if we learn to combine the knowledge about the systems with the artificial intelligence. But then it will allow us to reduce waste of resources from industrial systems, and it will, in the energy system, be crucial in order to implement the complexity that will arise from more green energy. Personally, I've been super impressed by ChatGPT and its ability to generate text. Unfortunately, industrial or hybrid AI is not nearly as developed. And that's because the industrial reality is complex. Direct use of AI and machine learning is rarely feasible in industry. And there are many reasons for that. We're talking about complex systems. They're built over time. They're not digitized. Take this cardboard factory here. It doesn't have a sensor. So we don't really know what's happening. There's not a lot of standardization, and even less if you go from one sector to another. Data, it comes from sensors, or maybe even from manual measurements. It's noisy, it's sparse, you have drifting sensors, and it's time series. So it's much, much harder to intuitively interpret than images or languages. And you might not even be able to measure what it is that you actually want to know. In this oven here, it's too hot. You want to know the temperature. It's too hot to put in a thermometer. It'll melt. So you have to infer the temperature from something else that you're measuring. And then, if you want to model something, you're quite often missing the labels. Because industry, they don't collect these labels. They don't label their data. And if you want to do unsupervised learning, you end up in a situation where, the normal is very, very complex, so it's very difficult to look for the outliers. So generally, this is challenging. And we're talking about safety-critical systems. The consequences of getting something wrong are very, very different from Netflix suggesting you a wrong movie for tonight. So if you suggest the wrong temperature here for the oven, you may end up burning down your factory. The advantage is that we have a lot of knowledge about industrial systems. There are a lot of experts who have gathered knowledge for a long time, and that can be used in combination with AI. And being the top emitter, of course, industry also has a huge potential for reducing emission. Let's look at Norway's CO2 emission. So the primary one is oil and gas extraction, so energy production, and the next one is manufacturing and mining, so producing stuff. And the third one is road traffic, which is transporting all the stuff that we produce around. I would like to give a couple of examples on how we can use AI in combination with domain knowledge to reduce emission from these top 3 sectors. To replace oil and gas, we need renewable energy sources. A lot of them depend on the weather. And that means that they fluctuate. And that's a challenge, because we don't have anywhere near enough battery capacity to produce electricity when the wind is blowing and then use it much later. We have to produce when we consume it. And normally this production is planned 12 to 36 hours in advance. But we all know that you can't really trust the weather forecast for tomorrow night, right? Okay, it might blow, it might start storming at 5 o'clock, or it might start storming at 6 o'clock. And that might not be important for me, but it's important for the power producers if the wind turbines start generating electricity or not. And currently, they replan based on this, they replan their plans according to gut feeling or experience. But if we start introducing a lot more fluctuations, then they will also have to replan a lot more often, and it becomes hard for humans to do it. So we've had this innovation project together with the electricity producers, Skagerrak, Evenue, and Equinor, where we used machine learning to try and predict this need for balancing, or this need for replanning just a couple of hours in advance to give them a head start. And we tried to capture information from the system in 2 different models. One is using a graph neural network to capture the transmission grid and the actual physical structure of the grid. And one is capturing the historical behavior of the data. And neither of the models have spectacular performance. They're actually quite bad, but they're better than random guessing. And they do tell you when they don't know. They do come with an uncertainty. And that means that today the operators, they're using these models as a support to humans in doing this replanning, and give them a few hours of warning. The second category is manufacturing and mining. And for manufacturing and mining, using your equipment for longer time is definitely a way of reducing production of stuff. And there we would like to use data to monitor conditions. But that will quite often only give you a notice like very shortly before your equipment breaks. Really what you want to know is what will happen far out in the future. For instance, if your wind turbine is inaccessible 3 months a year due to snow, you want to know what is the condition going to be in 3 months, or what is the condition in the middle of the winter where you can't go and see, but you can actually change the way that you're using it. So we could predict this based on the usage and the weather, but that would require very computationally heavy simulations. Instead, we want to have a fast surrogate model that can just tell you this all the time, pending the weather and pending the usage. But such a model, we would need to ensure that it is actually robust and that it only provides physical predictions, physically meaningful predictions. So for that, we're developing a framework where you're learning under physical constraints, for instance, energy conservation, to ensure that the models actually provide you physically meaningful predictions. We're also exploring ways where, due to physical knowledge of the system, we can use data of multiple resolutions, which is a challenge inherently for classical deep learning models, but it will allow us to exploit a lot more data. So this is an example where we inform AI with physical knowledge to prevent waste of resources, because doing predictive maintenance would enable optimal machine usage, and it would reduce unnecessary service and change of parts, saving both money and helping the environment. The third category is road traffic. I'm going to stay here for a moment. That's mostly transporting either raw materials to manufacturers or goods to customers. And there are many places of traffic and logistics where you can use AI. One of the ones that are maybe less obvious is in the packing of goods before they're distributed to shops. And that happens in the wholesale warehouse, where you have pallets of one type of goods coming in, and then you have to repack them and send them out to the shops based on demands in the individual shops. Today, that's human labor. It wears out people. So here, we're working with Solver, which is a small company who's trying to build this robot that can replace humans in existing warehouses. The problem now is that the current robot, the algorithm that controls how the robot is stacking, is worse than humans. And that means that we would need more pallets for the goods, which again means that we would need more trucks on the roads. That's not good. Then you might think, oh, I got all the way to the end. Then you might think that that's just three-dimensional Tetris. That could be solved by any game-playing AI like AlphaZero. But it's not. It's not a competition about winning or losing with a single partner doing or a single opponent doing things. It's actually a multi-objective optimization problems with a lot of different layers to it and a lot of interconnections to other problems. The main target is to get the stack as compact as possible, but it has to be stable. There's a physical constraint. It has to be transported around the warehouse. You want to optimize your route because the robot is quite slow, which means, again, maybe you want to optimize the warehouse layout. And also the receivers of the pallets, they have an opinion on how they want to unpack this pallet, so that also influences the problem. And then I haven't even talked about what you do if a box is missing or if it's not a quadratic or a rectangular box. So here we're trying to use deep learning to help an existing optimization algorithm. So it's a classical optimization algorithm that's getting help from an AI, which is learning something about the physics. We're trying to learn to recognize unstable stacks very early in the process so that we can say, hey, stop, you don't need to explore that part of the parameter space. And if we can make this algorithm to become 5% better than humans at stacking, 5% more compact stacks, then we would be able to reduce the number of trucks in Norway with around 200 truckloads per week from just one of the distributors in Norway. So I hope I've shown that the AI is completely necessary for lowering our CO2 emission, but it's only going to be possible if we combine AI with domain knowledge. And there's the challenge that we do need more research and development in this area of AI if we want to unlock this potential for emission reduction. Thank you.
Okay, while it's been setting up, my name is David Cameron, and I've been told by Morten Dalsmo to do an advertisement for the Partnerprogram for the Data Science Centre, of which I'm a manager. We have 6 partners at the moment, leading Norwegian organisations and companies, but we want more partners for that program. But what I'm going to talk about is actually something related to my research. About 2,000 years ago, there was a parable told about the importance of not just talking about things, but actually putting things into practice. There was a man who built a house on the sand, and when the flood came, it was washed away. So I'll talk today about actually building foundations on rocks for what we're doing about artificial intelligence. And the context of this is what we call a fringe transition. And what I've tried to point out here is that we have a system, and we're moving towards a system that is going to be incredibly interdisciplinary and tie together things which previously aren't tied together, and we will need to make decisions which cross between process, energy, and construction to make these systems work in the future. And to do that, we need to be able to make decisions. And my working definition of AI is about getting computers to do sensible things for you, to be able to support decisions that we make about how do we operate the power grid in the future, how do we create an equitable energy system, How do we cope with a situation where a builder suddenly says, I need 3 megawatts of power in the middle of Oslo next Tuesday? Those sort of questions need to be made. And around these sort of physical systems, you need to be able to do reasoning. And that reasoning has always been based on 3 things. Firstly, you need to know what the system is supposed to do, how it's built, and what its supposed function is. And so what we call the systems configuration and design. You have observations. You need to be able to measure something. Anywhere in the real world, if you don't have observations, you don't know anything about the system. So you need to do measurements. And since the beginning of time, we've been actually trying to simulate things. The ancient Greeks did simulation to predict when eclipses came, so that they'd know what was happening there. So we do the same, simulation analysis. Now, the point of actually making a decision is that we need to be able to synthesize that information into analysis, reasoning, and decision support, i.e. AI, so that we can make the world a better place. And so this is what I call digital twins. I see digital twins as being a pattern for making IT and the information we have about the world available to make useful decisions. But to do that, you need a foundation. You need to be able to have good data at the bottom. Because what we see from particularly these statistical AI methods, if you put rubbish in, you'll get rubbish out, and then the algorithm won't be able to tell you that it's rubbish. So, these digital twins are difficult and expensive, and the problem is that the world is a complex place, and data has a history to it, and data is put in different places, and people call data different things. So you can't get an overview. Can you get just the information you need? There's so many documents, and there's this truly evil computer program out there called Excel, which is used to solve most problems when you can't get access to data. And this is not a new problem. 8 years ago, my colleagues sent in an application to Research Council about something called scalable data access. We created an SFI called Sirius, which finishes in about a month, but will continue onwards, to look at this problem that we have lots of data, we can do lots of really good things with it if we can get access to the data, but people spend 80% of their time massaging the data to do that. And to solve that, we believe we need to be able to build good knowledge models to organize the data. We need to have standards so we are all talking about the same sort of data, so we don't have to use Excel to translate between things. And we need to do some systems thinking to solve these problems. Now, Sirius was an oil and gas project at the beginning, but what we've seen is as we've followed the engineering companies through the centre, it's become more and more a renewable energies and systems sort of construction. And this is a problem we have if you are trying to build any complex infrastructure. So if we're going to try to build the next power grid for a system, you're going to have a project, and at every point of a project, you throw a pile of paper at the next person doing something in a project, and you lose a lot of information. And that is the information which you need to know about why you've built the thing, and it's information you're going to need to know how to do the optimization later. And so our approach to address this is to say we need to move how we describe the world from documents. Yes, you use documents to approve, but what we want to do here is we want to move towards a data-centric engineering so that we can create objects that contain data which has a defined meaning for us, and it captures decisions and gives us a way to describe what we're doing. And if you do that with your data, you're getting a much more sustainable ecosystem for getting access to that data. And this is a slide which I've taken actually from my colleagues who are working with Equinor to build up a framework based on this, based on standards. And so what you do instead of building documents is you build up system models based on these data objects to solve the problem. And this is being tried out in a collaboration which actually, when I talk to people down in Europe, they admire us for doing it, where you get a group of companies, competitors and also collaborators, working together on what used to be called NOACA, but it's now sort of a pronunciation challenge for me, Yggdrasil, field development. Thank you, Aker BP, where we are working on a very complex field development, and the people involved, the engineers involved, have said, we are going to change the way and prototype out ways of moving from documents to data to create a good data foundation for us. And so they're taking all these information sets and working out and trying out the standards that we have in practice. And what I'd like to say into the AI context is that there was an interesting point made previously about that we need to be able to prove the logic of our decisions. One of the things I see with neural net AI is it's not logical at all. And so we really need to have a situation where we have machine learning as a valuable tool for us, finding patterns in statistical data, doing all the wonderful things that neural networks can do. But we need to be able to describe how we understand reality. So we have logic, which we can use to define the meaning of the physical models that Signe talked about, that we can use to train the machine learning, that you can use machine learning to model the uncertainty that's always in our models we have, and so that we have a framework to build a foundation so that the decisions we make in future are as good as they can be. Because we can't just magically say AI is going to solve our problems if we don't actually have the intellectual apparatus to realize that there is physics involved here, there is logic involved here, and we need to be able to talk to each other about the same sort of things and understand our knowledge. As a last slide, there's actually a Norwegian investment in the future ongoing around these standards. And this cluster of logos is the people that the companies that the serious working group at the University of Oslo is involved with. And we are working hard with those people to work towards a wide cluster of standardization efforts, especially in Europe, and towards IOC, so that what we do in Norway can actually be a beacon for the world in this area. Thank you.
So my name is Ingrid. I'm a professor of statistics at the University of Oslo. And I'm very grateful for being invited here to give you a brief description of a new center of excellence that is called Integreat, that is dedicated to machine learning research. Where is this here? Yes. Sorry. The center is funded by the Research Council of Norway. It's hosted by the University of Oslo and the University of Tromsø, and the Norwegian Computing Center are partners. The center involves around 60 researchers, and it starts up now. Next week we have a housewarming party, and then we have the official opening of the center in November. As a center of excellence, we will focus on methodological, generic development of better machine learning, or better AI. But of course, this will have also enormous potential for use in industry or research or society. The center has a horizon of 10 years, and none of us and none of you will be willing to predict what we will be working on in 2033, but at least we know what we will start with. So we have heard from the previous speakers, many of the previous speakers today, about challenges of contemporary machine learning. And this is my list now. Algorithms are fragile and lack robustness. Most methods lack transparency and explainability. These are things that speakers before me have talked about. Data and loss functions might be biased and discriminating. Uncertainty are not or poorly quantified. Algorithms depend on huge amounts of curated data and require excessive energy to train and run. And Integreat will do research in order to transform machine learning to address all of these challenges. And the vision of Integreat is that machine learning is mostly data-centric, depends on huge amounts of data, and it's not very easy to incorporate existing knowledge. Things we already know has to be learned from data ex novo repeatedly. And as previous speakers, the two speakers before me, they've talked about knowledge. What Integreat will do is to build what we called knowledge-driven and data-informed machine learning. That we argue will lead to more accurate, more sustainable, more explainable machine learning with appropriately quantified uncertainty. We have a very wide view of what knowledge is. It can be knowledge about structures, processes, and dynamics of systems. It can be knowledge about data-generating mechanisms, and the knowledge can be either exact or more imprecise, soft, or subjective. In the first case, it can be in form of must links, cannot relationships, logical formalizations, formal ontologies, and strict mathematical models. And on the other side, we have most likely links, prior beliefs, prior distributions, and stochastic relations. Knowledge can compensate for bad data, I mean small data, noisy data, bad data, such that we can solve problems that otherwise wouldn't be possible to solve. We think that by using knowledge, we can save energy by especially using more parsimonious models and more sparse networks, for instance, so less parameters to estimate. That will save us energy. And also we will work on knowledge-driven methods to compress and reduce data while controlling the loss of information. So that is also a way of being more sustainable in machine learning. Then we will work on proper ways of quantifying uncertainty. As we have heard many times today, data are incomplete, noisy, and inconsistent. Also, knowledge and models are imperfect, and algorithms are approximate. So the results, which are estimates, predictions, or decisions, are uncertain, and in order to have trust in them, we have to provide the uncertainty around them. And we will work on representing and modeling multiple sources of uncertainty probabilistically, and we will use uncertainty quantification to reveal disagreements between data and knowledge or between different data sets. And by combining knowledge and data, if we have good knowledge, we will certainly reduce uncertainty of solutions. There's been many discussions about explainability before today. The first thing I can say is that declaring knowledge, of course, allows it to be criticized. We also will aim at understanding inner workings of black and gray boxes by providing them with knowledge-based, explainable white box components. And this, of course, reminds a bit about what Signe and also David talked about before me. There is, in the last years, a lot of activity connected to what is called physics-informed deep learning or hybrid modeling, as Signe talked about. And we will also do that. Hybrid modeling will be one way of doing knowledge-driven machine learning. But what is special for this group of researchers is that we integrate machine learning, statistics, and logic that represent different ways of learning from data and different ways of representing knowledge. Machine learning is inductive and learns about the world by examples. Logic is deductive with rules, principles, and reasoning, describing and representing knowledge. While statistics, that is my field, is inferential, learns models, and quantifies uncertainty. I wanted to make just a small example that should be as different as possible from what I imagined that Signe would talk about when it came to physics-informed models. So this is from preference learning. Preference learning is when you want to learn preferences or do rankings used in marketing, psychology, social sciences. And we have the data that we have are simply just partial information from many users about a set of items. For instance, it could be movies, as Signe was mentioning. It could be books, it could be scientific papers, whatever. What we have is some information about preferences of pairs. Like, I like this movie better than this movie, and this movie better than this movie. This kind of data comes up when you click on something on a list. What you click on will then be coded as something that you like better than all the others. So that's how this type of data comes up. And what you want to do from it is to estimate individual preferences of all the items for each of the users, to use that for recommendations, for instance. So often people are inconsistent in their preferences. A consistent user would do things in a transitive way, so that if, what I have written here, if one is better than, you like one better than two, and two better than three, and one better than three. That's consistent. But you could have various types of inconsistencies, saying, for instance, I like one better than two, two better than three, and three better than one. That's not logical. Or I could simply end up with saying once that I like one better than two, and another time that I like two better than one. So how is this really handled in preference learning? Well, the usual thing to do is just to forget about such confused users. But we can also use knowledge about humans from psychology. So if we say that similar users share preferences to some degree, that means that me and my friends, we tend to like the same things. Then we need, in order to model that and then combine this knowledge that we model with machine learning, is to have a measure of similarity of users, and then use the one of those two confusing preferences that my friends that are similar to me have indicated that they like. Or I could go even further and say that, well, when people are inconsistent in this way, it means that they are very uncertain because the items are quite similar for them. That means that I could also build into my model of the knowledge that I have that such an inconsistency, that is a good information to use, because it means that A1 and A2 are close in preference for this user. So this is types of knowledge that can be formulated that is very different from the physics described by differential equations and so on in the standard hybrid modeling. This way of combining, this is formulated with statistical Bayesian priors and so on, of formulating knowledge, functions very well. And now we are thinking to how we can use the language of logic to handle also such consistencies in an even more refined way. So this new center, as I said, it builds on a team of researchers that come from different departments, even different faculties, statisticians, logicians, machine learning researchers, and ethicists. And we will develop theories, methods, models, and algorithms which exploit knowledge together with data. And we will solve important real-world problems in science, industry, and society together with domain experts. And if you want to read about our plans or in the future follow what we are doing, please go to integreat.no. And thank you.
All right, so I am going to give the last talk of this session. It is somewhat in line with the previous speakers, but also somewhat not. Perhaps more aligned with what we've talked about earlier today when it comes to how do the ecosystems look like. Because I would like to describe the Swedish ecosystem. We got a nice introduction to it this morning, but I'd like to describe certain aspects of the Swedish ecosystem in a little bit more detail. So my name is Professor Amy Loutfi. I am a professor of computer science at Örebro University. I've been doing research in AI since the late 90s. My particular research area is on the integration of machine perception and human-robot interaction. So I'm interested in how perception and interaction contribute to intelligence and learning. And I've been working with different components of the Swedish AI ecosystem for quite some time. At Örebro University, I have a position of pro-vice chancellor. That means you look at certain strategic areas, and I look at AI and innovation. And we heard about WASP, and within WASP, I am co-director. There are several co-directors who help our director, Anders Hansen, at Linköping University, and we work on different areas as a team to focus this particular investment, and I'll talk a little bit more about that. Now, like you've heard in this session, we've talked a lot about sort of the AI technologies and where their shortcomings are, but also where the opportunities exist. And I really want to give a shout out, particularly to the speakers that have been talking about integrative and hybrid AI. These are really important areas. And in fact, I think as an AI researcher that's been around a couple of decades, I feel very old when I say that, but it's true. You know, you start to see the trends that are emerging. Often when I'm out talking, everyone says, oh, everyone was very surprised by ChatGPT, but I don't think AI researchers were so surprised. I think we've seen it coming. We saw this trend on the way. And if I look at some of the things that are bubbling and of some of the things that we're talking about, I put my own little list here. Of course, we're talking a lot about generative AI. Deep learning's been around since, 2014, 2015. Federated learning, I think, is also a very interesting topic. Perhaps it needs a little bit more maturity to be extended beyond what we're talking about it now. Reinforcement learning, particularly coupled to areas like robotics, is an extremely hot topic at the moment. We talk a lot about the need to have a lot of data. And I think one of the things, if I were to bet a little bit of my money, is that I think AI researchers are going to be able to kind of loosen that constraint in the short future. Not just large language models. We talked a little bit today about smaller language models, and I also hope we're going to make some progress in few-shot learning, as well as seeing AI coming closer and closer to the devices upon which they're working. And there are more, and there are more, and there are more. What I really want to convey here is that, as I said before in the panel, AI is a broad field, but AI is also a very, very fast-moving field. And some of the discussions that we have today may not actually be relevant tomorrow. But AI, I think, is definitely here to stay. So aside from the particular technologies per se, the question is, how does a country work with structures? So how do we go beyond the actual topics and really try and develop our ecosystems? And here I would like to give kind of the perspective from the Swedish ecosystem. Many of us who have been working in the Swedish ecosystem, we try and paint it or give sort of a pictorial view, and it looks something like this. And I think it's probably not all-inclusive. There's probably some aspects missing, but I think the main components are there. So we have a very sort of large research initiative, and I'm going to spend actually quite a bit of time talking about WASP, that look at basic or foundational research in the area of AI autonomous systems and software, but it also comes with a number of what we call sibling programs. And these sibling programs look at AI from the perspective of humanities and society research. We look at the combination of AI and data-driven life science. We're also now looking at the combination of AI and material science. And a lot of this is funded, of course, by the Knut and Alice Wallenberg Foundations or other Wallenberg Foundations. But there's also the need for competence. And it's competence in many different forms. We need universities to kind of rethink and revamp their university educations. Lawyers need to know a little bit more about AI already in their education. Doctors, the same. But we also need to look at lifelong learning. Upskilling and reskilling is as equally important. And as we heard earlier today, there are those actors that are very important to also support the implementation and operationalizing AI and supporting the applied research. And we have AI Sweden, we have RISE, and we also have funding agencies that enable these actors to do these tasks. And then, not least, we need to have an ecosystem that looks at the public sector. This is perhaps a very, very critical area, particularly in the Nordic countries, is how do we help the public sector? So this is the kind of ecosystem in short. And the key here is how do we get the pieces of the ecosystem to really work together? And I hope I can touch upon that in my next few slides. What I can say from my experience is that we're starting to get better and better at it in Sweden, but there's still a ways to go. So what I'd like to do is I'd like to just focus on the research aspect. And in particular, I'd like to focus on the one that is close to my heart, which is the WASP program, which is, as I said, AI, autonomous systems, and software. And the name is very interesting because it's a name that has grown. It started off as being the Autonomous Systems Program. It included software. 2017, 2018, it also realized we have to put AI in here. And the next step is cybersecurity. So it's a very large program, and it's a program that spreads over several universities. So here you have the main universities that are part of the program, but then there are also particular groups where you have, let's say, clusters of researchers that are working in this area and have basic research in this area at those universities, those 3 affiliated groups. And it's funded by the Knut and Alice Wallenberg Foundation, which means that it also has a very clear sort of mission and strategy, which is to conduct foundational basic research, if you like, in the areas of AI, autonomous systems, and software for the benefit of Swedish industry and society. This is quite important. And here it is achieving this by building a world-class, basically academic landscape where companies are also tightly involved in this research. And just because we say foundational research and basic research doesn't mean that we don't work with companies. Those 2 things actually go hand in hand, because it's often when you're working with the companies that you can elicit those basic research problems. Now, a little bit about the program in terms of numbers. Someone said that there was an initiative, 1 billion for Norway. That's good. 2 billion is even better. 6.2 billion is also good. So it's a 6.2 billion program, but it's a long program, 16 years. Very high focus on recruitment and talent. And in particular to run a graduate school that has 600 PhD students, or 600 graduates, we can say. We also aim to build new research groups, and a total of 80 new research groups should be established in Sweden. And a program of this size, of course, has to have a number of different instruments. So it has a research program that kind of outlines the main areas. As I mentioned, a graduate school is very important, where we're really trying to put in new courses, important foundational courses, so that everybody who has a PhD in AI autonomous systems knows the basic building blocks and more. We work a lot with recruitment. I'm going to talk about the research arenas because they are relevant also to how the ecosystem can collaborate with others. Internationalization, and here it's very interesting to see what kind of collaborations we can find within, for example, the Nordic countries, but also with other countries. And we run a lot of events. Now, just to talk a little bit about the recruitment. So, as I mentioned, 80 new research groups. And when we went out, particularly with the recruitments in AI, you realized it's almost like the Hunger Games, because everybody is trying to find that talent. And the way in which we've worked with VASP is to try and really provide generous recruitment packages and to find talent with a very nice background and diversity. So we've brought here chairs, so these are senior recruitments who come primarily from other European countries and have relocated to Sweden to conduct research in AI autonomous systems. But we also work a lot with the assistant professors, and the assistant professors get this basic recruitment package of 2 postdocs and 2 PhD students to come and be an assistant professor and start building your own research group. And these are just a few of the faces of the people that we have recruited. We heard a lot about combining machine learning and reasoning. We have some recruitments who are particularly good in that area, and really trying to lift Sweden in terms of its competences. And it was nice to see because, you know, a couple of years ago, if you look at NeurIPS and see how many publications are coming from Sweden, maybe if you were lucky, there was 1. And just yesterday, we compiled the list, and we have about, you know, in the next NeurIPS, almost 20 papers coming from Sweden. So we've really made a step change in the competence. Now, how many PhD students do we have today? We have actually a little bit more than 400. So they are active PhD students. 100 of them are industrial PhD students. 90 have defended. And I'm going to give you a little bit more of these statistics soon. And then who is engaged? So who is part of the VASP family? We have about 1,000 people that we consider sort of VASP faculty. That's quite a lot. We work with both smaller projects, so we have calls for industrial PhD students, academic PhD students, but we also work with larger projects where we get those research groups working together. And we also work with projects where you can also get a little bit of resources to do some engineering, because researchers also need to do engineering. And particularly when we're working with industry, we need that help. And I mentioned that, we focus on also being relevant for industry and society. And one mechanism with which we do that is something called our VARAs, where we look at particular topics that have a high industrial relevance. So we have one, for example, on robotics that is run by ABB. And we have labs in ABB where researchers can come work on joint data together. There was another one in media and language. This was the VARA that actually collaborated with AI Sweden and developed GPT-SWE. And also on public safety with Saab and looking at ML ops as well with Ericsson. So really trying to see how we can, as I said, be relevant for the Swedish landscape. Now, I said I would give you a little bit more numbers, and just to show you that. So in terms of things like publications as a researcher, I mean, you're always looking at these bibliometrics. I think the thing that I would like to kind of lift is that when we look at things like industrial co-authorship, it's quite high for being an initiative focusing on foundational research. When we look at aspects like international co-authorship, because we should remember AI is, of course, and research is very international, it's also quite high. When we look at other aspects, like, for example, whether or not we can actually get a return of investment, I don't like that term, but whether or not we can bring even more opportunities to Sweden. We see the researchers that are involved are bringing these ERC grants, which are very, very good European grants for doing research. We see they're still working with the National Research Council. So what we want to see happening is that WASP isn't necessarily being the only initiative, but it's also encouraging other initiatives. Again, the ecosystem working together. And the number of graduate students that we have, and these are the numbers that I thought were very interesting to lift today. So we now have the program. It's been running now for a few years, so we're starting to see our first graduates come out. We have about 95 graduates, which is very good for us. We are producing 1 PhD a week. So that gives you an idea of the output of the talent that is coming out. But what's even more interesting, and what even surprised, I think, many of us working with the program, is of these 95, we have 63 that are employed by Swedish industry. Keep in mind that in this particular group, we have about 50-50 who are from Sweden and who are coming from the outside. Later in the years of WASP, it becomes much more international, but the point is that they are, in fact, staying. So what I want to say is that, these kinds of initiatives, these basic research initiatives, from the perspective of WASP, is really showing to give some effect. So that was WASP. As I mentioned, what I really wanted to do was sort of highlight what it is, but also lift the fact that we are working, in this notion of an ecosystem. And I realized, of course, this is a talk that is given to people who are policymakers, CEOs, leaders within different types of organizations. So I just want to go back to something that I said on the panel as my main takeaways. So if you have an ecosystem and you can build the structures of it, my advice to all the leaders in the room is to use it, but also to mirror it. And what I mean by that is that you mirror the ecosystem that may exist in the national level, in the Nordic level, in your own organization, which means you might have to start looking at different components. Components like how are you driving R&D, components like how do you do the implementation, but also how do you work with competence. The other aspect is competence, and I put it here 3 times because it's different kinds of competences that you sometimes need. You need competence of those experts. You need competences of people who know how to tie it to business models. You need competences also in terms of, for example, lifelong learning, upskilling and reskilling. What we've seen from other places, like, for example, Canada, that has worked on how do you implement AI into business, is that they always say that it comes down to finding the right use case. So really work on which use case for your organization gives you the most value. This is a non-trivial thing to do, because often you think you know the right use case, but you really have to integrate with experts to figure out what that is. And finally, as I mentioned at the panel, and I just wanted to reiterate it, we're ready now to start nuancing our AI. And you heard what the trends were in AI. We talk a lot about different types of technologies. And when it comes to industry, I anticipate that there will be a lot more coming out of the AI community, especially in light of these investments. So dare to nuance when you talk about AI and talk about the specific technologies. Great, thank you very much. Sorry.
My name is Rebecca Adler-Nissen. I'm professor in political science, took the wrong turn at some point and ended up director of social data science in Copenhagen. And I've built a master program combining social science and data science. So you are also my data, and that's wonderful. We will experiment a little bit here in this panel, because it will both be a panel. I can ask the panelists to come up already now. Morten Dalsmo, CEO for Sintef Digital. Anders Hansen, that we've met, professor at Cambridge University and IOE. Ingrid, you're all familiar faces. Claes Petersen, CEO Nora. Kasper Klynge, Senior Vice President, Danish Chamber of Commerce. And Salah Fontaine, hope I pronounce your name correctly, Group Chief Data Scientist at SEB and Investment Manager at Naviga Ventures. And what we're going to do now is not just to talk, but also to reflect a little bit on what we've experienced these past 2 days. I take the liberty to cut the questions that I had prepared a little bit. So this is going to be a collective exercise. What we're going to do is basically ask ourselves, each of you, what is the most important thing you're going to take away from this meeting? And perhaps even more importantly, has this event changed your mind on Nordic initiatives within the AI? Is there something you've experienced that has changed your mind? Okay, so that's the basic question. While you're reflecting, we will simply ask the chatbots up here about that question, so you don't have to answer yourself, but you can sort of nod or within yourself, right? That's how we're going to do, because once we're done with this, we will transition smoothly into the very, very last part of this panel, and I promise we'll end on time. That's my only job as chair, with Bo Lidegaard and Morten Dalsmo, who will, together with you, draft the conclusions and what will happen next. So stay seated. This is going to be a little bit of an experiment. So the real question now for the panel, and we'll just go this way around, is...
Before I fall over into...
Exactly, because it does look a little bit dangerous from here, is basically what you take away, and if you've changed your mind on anything. You have 2 minutes each, and I will hold up this red thing, which is the report that I made together with some other experts on, for the Danish government on big tech and how to handle them. And it says control, so that's why I'm using that, if you use more than 2 minutes. So Kasper Klynge, we start with you. What do you take away from this meeting?
Yeah, no, thanks very much. I mean, first of all, I think it's a great opportunity to have Nordic conversations around the AI, so kudos to those who organized it. And then I thought I would, in the best tradition of being Danish, being very blunt, so there is no filter between what we think and what comes out, as everybody in this room will know. Perhaps say one thing that I don't think we've used enough time on in the last sort of 24 hours, and that is the question about the future of Europe and European societies, European companies, because I think when you look at the development of the tech industry, and especially when you sort of put the artificial intelligence on top of it, and I spent 3 years working for one of the big tech companies, I think one of the...
Microsoft.
Fantastic, thanks for that. I think one of the big challenges we stand in front of is sort of the winner-takes-all aspect of the technology industry. And, I was speaking at a conference last week on cloud, and there was a company who said, we're very proud, our company is growing 8% per year, but our expenses to the cloud is growing 30% per year. So I think what we're standing in front of when we look at it from a European perspective or from a Nordic perspective is actually sort of when you add AI onto cloud productivity tools, there is a fundamental question on whether we will have access to competing technologies or competing companies providing the technology that is going to be essential for most of our companies. Now I work in sort of a business association, and what has been very interesting for us is we've been speaking to these sort of 18,000 companies that are members with us, and there's not been a single one of them, small companies, very large companies, even some of the biggest Danish companies, who haven't said it's a huge problem for us because we don't have the possibility of choosing between different companies when they provide us with the technology that we need. So I think the competition aspect is something we should spend a lot more time on. I'm not very optimistic in this area, so I think, and this might come as a surprise representing a business association, I think we do need regulation also to make sure that we have competition in this area, not least in Europe.
Thank you.
You didn't raise it, was it
no,
within?
It
I felt a little bit stressed, but...
It's stressed, but it's good.
Okay.
So monopolies, the problem of tech monopolies, or at least tech domination, is real. I'm not sure that that's going to be what you take away.
Nope,
or
nope, not at all. But it's a good point. I completely agree.
Yeah,
so I currently work with deep tech investments, and before I used to be the chief data scientist, and I've worked with AI for maybe the last decade or something like that. So I know Amy quite well, for instance. Great talk. And I wrote down some stuff because I can speak it forever, and I have 2 minutes. So I think one thing, how many of you have been to a mine lately? Yes, some people have actually gone to mine. There's a lot of really cool autonomous systems driving around down there and taking away the dangers of a lot of the work that was super dangerous before. So I think when we speak about AI is coming, it's kind of already here. And then I think our sort of challenge is always how we can make the foundational models, the opportunities really explainable. So working at SEB and then in IKEA, I worked with business people trying to explain what it was that was possible. And it's really difficult to find those examples that make the imagination open. And it takes time and it takes patience and trust, which I think has been a key word here today. And then I have this sort of, we don't always need AI. I think we're in this massive hype where people are talking about the revolution of first deep learning, then large language models. And actually, I think there are a lot of more sophisticated ways that we could be doing things. And I don't know if you've seen the Nobel Prize winners from last week, but the professor who won the prize for quantum dots, keep that in mind. Like, she did excellent research for a really long time, and she was moved to a small little lab. Nobody really wanted to collaborate with her, and nobody was publishing. Let's not do that to the fantastic researchers that are daring to do things a little bit different. And let's try to sort of support them as well. Yeah.
Well, I couldn't agree more, but I know that trust is a key thing you take away from this meeting. Yes?
Yeah, I'm really inspired by this event, and I think that first of all, what I have learned is that you really have to understand how to balance between regulation and innovation. Regulation is extremely difficult and hard, and I'm glad that there are experts working on that to make sure that we get the best regulation in Europe. But I'm not really that optimistic, to be honest. It's really a complicated subject. But actually, to find this right balance between regulation and innovation is extremely important, because I think, especially for the businesses in Europe and in the Nordics, there are a lot of opportunities in utilizing AI. And I think that the consumer-to-business market is lost for us. But the business-to-business market, there are opportunities in that area. And I think, again, using this word of content-specific, knowledge-based AI, that is a specific field of AI where I think we have big opportunities in the Nordics, where we can use our domain expertise in various industries and combine that domain expertise with AI expertise. as has been shown here. So I think that is an important area where we should cooperate more. And I'm really optimistic on the opportunity and the potential that lies in more Nordic cooperation. I think there are big opportunities for that, but I think also the governments in the Nordics need to facilitate that in some sense, because for us as a research institution, it is not that easy to make this happen. We can collaborate in the EU, in Horizon Europe programs, that is possible, but actually to make also some funding available for Nordic cooperation, I think that is important, and I'm really sure, having listened to for instance, what is happening now on the national language models, I think that is an area where we certainly could cooperate even more than we do today.
Great. I'm sure we will see whether this will be reflected in the conclusions. I would, though, challenge you a bit on the balance stuff. There's a recent paper by Anna Bradford on exactly that, where she says the false dichotomy between innovation and regulation. And I think that there's a move, just as there's a move within AI research, there's definitely a move within what we could call data governance, which sort of tries to look exactly at wiser forms of regulation, where you don't have that choice, really, because I think we're beyond the place where we say whether something should be regulated or not. It's the way in which it's governed or regulated or managed. But yes, I take away also the domain knowledge, the combination of that, and the need for Nordic cooperation funding, and also for governments to step up on this, because researchers and companies can't do this. Great. Yes?
Yeah, if I've changed my mind, maybe I've changed my mind. I started my talk by showing that in Copenhagen we kicked out the physicist and introduced the AI people as new heroes. Maybe I have changed my mind. We need domain knowledge. We need to kind of put those restrictions from nature into our model. We don't have data enough always to do pure kind of data-centric models. But also still, some of my thoughts, I think, have been strengthened. I mean, we need Nordic collaborations. We need, I think, language models is kind of one obvious field, and they are developing to multi-model models with pictures, with sound, and so on. This is an excellent topic of collaboration, and with so many great examples here. I still think also that health is of particular interest. So those have been strengthened, and I think also we had some excellent discussions actually in the breaks about these things. So breaks are good.
That's a good takeaway. Breaks are indeed good. And also you were confirmed in your initial ideas, but also that physicists are still needed.
I'm a physicist myself, by the way. So
you haven't made yourself superfluous yet. Anders, yes, over to you.
Right. So I think my main takeaway is about regulations and the importance of regulations, and I think it's been a very interesting and great debate about this. It seems to me that there are essentially three different paths, not completely different. There's China, no regulation, seems. United States, some regulations, but much less than Europe. And the big issue is the balance between regulations and innovation. But I do want to make the point that also regulations can stimulate things. And I want to make the example of 2008, after the financial crisis. I lived in the US at the time. And you remember that General Motors almost went bankrupt. It had to be rescued by Obama, literally. Chrysler was bought by Fiat. But there were companies that survived. Ford did not need government money or didn't have to be bought up. And Toyota was able to thrive. And why was that? They had sold cars. Ford had sold cars on the European market that had been heavily regulated regarding the size of the engines and the emissions. And Toyota had been selling cars in Japan with different regulations. So they could compete, and suddenly the Prius was the most popular car in the United States. Suddenly, that type of regulation was now giving a benefit to these companies. I'm not saying that this is the solution to all problems, but I do want to point out that regulations also stimulate both research and innovation in potentially the right direction that we think. But that's a democratic and political issue. But I think this is the main takeaway from me here.
Thank you so much. So the way in which regulation can even stimulate innovation, or that's at least the point you want us to take away. I guess that's a better way of framing it. Ingrid?
Yes, as the last one.
Yes, last but not least.
Yes.
Not least.
So I have found this meeting very beautiful in a way, in the sense that people here know what they are talking about, and it's not scaring people as is so much happening now in the media. And at the same time, there is nobody here that is sort of overselling anything. So I like this atmosphere of people in a sensible way about artificial intelligence that is missing in the public debate nowadays. Then I think that, as it has been said by many here, that collaboration is important, and to be bigger is better, and so on. Nordic collaboration, of course, but in a way, maybe it's too late now, but I would have wished that the whole world would collaborate, would have collaborated against the big tech companies, in the same way as happened with the Human Genome Project in the 90s, where a private company was trying to sequence the whole genome, and all the states did it instead together and made it openly available so that it wasn't a business concept anymore. Probably too late now, but that's what we should have done.
Can I just say something so
yes,
you don't feel so bad?
Yes.
No, but I agree. But I think when you look at large language models, that's kind of exactly what's happening. The open source community is incredibly active and creating loads of really good models, and it's such a beautiful thing. And I think in general, working with data practitioners, they tend to be very collaborative, and it kind of opens up those doors. So I think we shouldn't give up just yet. But when it comes to the technology part, we need to be smart.
Right. So both on a hopeful note, I guess, from Ingrid, and also reflections on how things could have been different, but also that they might be different in the future because we don't really know it. And that's, I guess, one of the takeaways that I also have, that while we're sitting in this room next year, some of the things we will have said we know are already outdated, but I agree on the tone. It's a beautiful tone, is that the right word? It was at least frank and not neither hype nor the opposite. Thank you to the panel. Let's just give them a hand. Thank you so much. Because while you step down, I guess, what will happen is that Bo and Morten, Bo Lidegaard and Morten Dalsmo, will actually present things that you will then draft together with them. So what's going to happen is that we will present some takeaways, especially what is going to happen, things that we are more or less in control of. Yeah? It's warm.
I'm not going to sing.
But this is the moment where the audience, you come into the picture. Yes. Yes. You go first.
So what we have tried to do here is to draft up a very short summary of takeaways from this meeting. And obviously, this is not a negotiating forum, nor is it a consensus-making forum, but we do think that it is important, as we conduct this series of meetings, that some major takeaways are preserved and communicated, and it is really, for all of you, when we have run through them, to take ownership to them and share them in the various contexts that you would like to share them. They carry the weight of our collective wisdom, but they do not commit anyone specifically to anything, as this obviously is not the nature of a meeting like this. But we have simply set up a couple of paragraphs, and Morten will just take you through it, and this is the time for you to raise your hand, contribute, discuss, protest. Nothing will be heard because we need to conclude in 20 minutes, but we might listen. Nothing promised.
Okay, thank you, Bo. We have made 4 findings and statements. And trying to put this together, we can start with the first one. I think we shall be quite satisfied with ourselves. We have a large AI community in the Nordic countries. We have a huge potential. And what we need to do, we need to strengthen our position in Europe. And there is a pressing need for strengthening Europe, the European stance on the matter spanning from fundamental AI research to application of AI solutions in tackling societal challenges and in achieving shared objectives. And I think that's the statement that we have heard a lot about. That's the first one. It's quite general, but I don't think you disagree very much with that one. The second one has to do with the AI Act. The AI Act will come, and it will come soon. I think the Nordic countries has similar values. So taking position and being front-runner on trustworthy AI is something I think we can agree on. And, of course, understand and utilizing what's coming up. And it has been said, the balance between regulation and innovation, and it's a difficult balance, we have to find it. And as Anders pointed out, regulation might also point the direction towards for the research itself. The third key challenge has been mentioned by many people, taking domain knowledge into AI algorithms, and that has been mentioned around. Ingrid has talked a lot about it because we have a new center. And of course, secure that the learning processes in AI is based on high-quality data. And high-quality data is important in many areas. And for example, one area where it's very, very important to have high-quality data and where we have high-quality data is in health and medicine. So we have a huge possibility. And it has also been mentioned, and it's at least one of the very, very important thing, at least what I want to work on, is that AI must be green. AI is using energy. AI is using materials. We have to think in better ways of collaborating in order to do this in a resource-efficient way. Anything you want to add, Bo, to this? 4 points?
No, I actually think this is the moment to pause for a second and see whether there are any of you who have comments to this or further points that you want to raise or want to include.
Yes. Oh, yeah, we have 2 over there. Yeah, we can share this one, Bo.
Hi, yes, my name is Johan Harvard with Silo AI. So one idea could be to extend point number 2, because I know Norway recently announced the upcoming launch of a regulatory sandbox for safe, trustworthy AI. I think that could be something that the other Nordic countries could also gather around and do something jointly around that. Spain announced this recently as well, but we could be really a good testing ground, not just to do research, but really put it into use as well. So that could be something to maybe extend point number 2 on.
My name is Dan. I'm an AI entrepreneur. I would like to protest a little bit, especially towards point, I think it's point 1 and 3, or 1 and 2, if you can put it back up. The first one is about the fundamental research. There's been a lot of talk about developing Nordic foundation models, and that's a terrible idea, and it will never succeed. So you should probably take away the fundamental research and put more emphasis on researching in applying AI. And the other point was the trustworthy AI. Trustworthy AI is a non-starter. It doesn't exist. It's a word from the talking class. And it was actually proved, and I think it was Anders that proved that you cannot trust whatever comes out of a model. So that's the two main protests.
Yeah, my name is Finn Hugo Markusson. I'm from the Ministry of Education and Research in Oslo here. The first point was something like you need to strengthen research from everything. You need to strengthen everything about AI. The problem is that such a statement is hard to implement, at least in the ministries when it comes to funding. So if you could continue with the three first most important steps to take, or something like that, then it would be useful.
Well, yes. Yeah, I think we just need to revert to the. We were a little bit preoccupied here with getting the.
Projected to work.
Yeah, I got the trustworthiness point, but I think were you pleased with the answer you got from Anders, from Morten on that?
Okay, I tend to disagree, but because I'm a strong believer in basic research as a fundament for good applications over time. So, we can call it basic research, maybe. Should we? We had a question here about prioritizing areas.
And to that, I will say,
Sorry?
I agree with you.
Okay.
And
Sorry,
if you are able to formulate 3 tangible actions that the audience agree to, that we can put into the conclusions, I'm happy to do so.
Yeah.
But I'm not going to do it here, standing in front of you and making that trial. But you are, of course, right, that any recommendation of that sort should be very precise and operational. But
okay.
At a meeting like this, it's very hard to do that.
The whole thing is going to be recorded, and so we will listen carefully to what you said. Yeah.
Tidying up.
Yeah.
I think we have here and in the back.
I think that there's first there.
I have the mic, so I'll speak a little bit. So there are 4 points there, and I find myself reading them and nodding along. They seem reasonable. But I find these points very difficult to act upon. I don't know what I should do when I get back home and people ask me, so what did you learn at this interesting event that you told me was so interesting? And, I don't see the agent in this. AI itself must become greener. I think we all agree, right? And you want to work on it. You just reveal that this means you will be doing something, which is great. But I don't see who's doing something in these points. And they have different agents, just as a fairly experienced proofreader. There are different agents in all of these points, but they're unstated. Yeah. And you should state them so that we know who are we speaking to in these points. Who do we expect to sit up straight in the chair and do something about it? And I'd be glad to act upon all of these.
We'll take a couple more. I just say we are in no position to instruct anyone but ourselves. We are not even in a position to instruct each other, but we are in a position to be inspired by each other.
But the last passive there.
Okay, I can make it. Personally, I can make it more active. I work a lot together, for example, with Anders Hansen in Sweden, and their investment in hardware, and we have to do this together in order to become greener, for example.
What is that thing to do? Yeah. And so, now I'll stop here, but you see my point. Also, another point is that there should be more about engineering here, because many of us spoke about it earlier.
Yeah.
I think we take a couple of more comments now. I can see there's a lot. This is the danger of opening after a long day without questions, and you will be shut down very, very soon. But let's take a few more comments. I actually think that we had.
Yeah.
Okay.
It's one here.
2 down there,
and then down. And then we take those.
And then we close.
Yeah.
So my name is Rasmus. I'm from 2021 AI. I just wanted to. One of the things that I feel is important, and I have seen some lagging of, is collaboration across the Nordic countries, both in terms of the research work. There are some good initiatives, like in Finland there's a research network on AI across the Nordics, for example, which is really good. And in terms of Nordic investments on companies, there are also good initiatives. Nordic Innovation, I think there's one of them here today, which is actually going out and funding cross-Nordic projects. So there are stuff happening in the place, but I would like that some of these initiatives are sort of better put in place in the Nordic region.
A couple more back there.
Yes, thank you. My name is Olivia Reckman, coming from Nordic Innovation and part of the Nordic Council of. So I just want to make just a small comment. We're really following this with great interest. There is a really clear vision from the Ministers of Trade, Business and Industry in the 5 Nordic countries, and that's for the Nordics to be leading in digitization and also ethical AI and responsible use of data before 2030. However, there is not much funding on the Nordic level, so I think that's something we fully agree on, and I think that's really important to lift that up. That's been a part today, that we need more funding if we should, because it's great to have an ambitious vision, but if there's no muscle behind it, it's difficult to do, and that has to do with the national budgets. So that's kind of what I want to underline, and then also just come and talk to us, because we work towards Nordic businesses. And we put together through an open call a Nordic ethical AI expert group that's going to come with clear recommendations, kind of answering some of the comments here in January, February next year. So thank you.
We have one more. And then, sorry. Yeah, there are two more. One there and one over there, in the white shirt.
Hi, everyone. My name is Christina Pamela, and I'm the global deployment lead in a big pharma diagnostic company called Roche. And we're based in Basel, so I try to see this from a more international perspective. When I sit with innovative AI solutions that can be deployed in healthcare, which countries in Europe would I go for? Right now, to be honest, I wouldn't go for the Nordics, because we don't have a digital reimbursement system. We say that we are proud that we are AI ready. That's not the case if you want to implement. So I would say we need more on the list. We need a bigger data sharing platform that goes across public and private partnerships across Nordic countries. And we need systems like we see in Germany, for instance, and the UK, where they're very progressive when it comes to digital health reimbursement. So that's my call. There was someone else down here.
Yeah.
And to follow up on that, we've been talking a lot about collaboration across the Nordics, and we've been hearing a lot from the universities, which has been really, really inspiring. What I'm missing is the collaboration across universities, businesses, and other institutions, because one thing is research, but research is really nothing worth if it never gets applied to our society. And where we should be front runners in the Nordics is in the application of AI to the benefit of our entire society. So I'm really keen to see more collaboration across the different sectors, and with a focus on how can we actually use the research in real life application.
Maybe we should, before we proceed, show you the next 2 slides, because that is actually to some extent answering some of these remarks. So this is perhaps what is more contended, but still highlighted at the meeting. So just leave it there for you to read for a minute, and then we have a more operational slides coming up.
Yeah. So this slide, we have talked a lot about large language models. We are doing a lot in all Nordic countries. We still can do more together. And we are not saying that we are not doing anything together. There are collaborations, but we can really extend the collaboration on the Nordic languages and large language models. So that's one statement. I think it's easy to agree. We do a lot. We have a lot of opportunities. We have to go into the foundations of what sort of infrastructure we need. Many of you have mentioned the access to data in order to make good models and so on. So I think that's a fairly low-hanging fruit from this group. The second one is that the Nordic country has opportunities on the energy side. How that can be formulated and how that can be done, we know that AI, machine learning, deep learning techniques can be used in order to improve the speed of the energy transition towards the age of renewables. How can we do that together? The opportunities in the Nordic countries is large, also because we have hydroelectric power at a level that few other countries have, but also the fact that we are, for example, in Denmark and Sweden, compared to Norway, has a lot of projects on wind and solar where we can join in. The third one is, of course, health. And as many have said, the health data in the Nordic countries is very good. We have good regulations on GDPR. We have systems that we can handle sensitive data. And of course, AI is strong in the area of medicine and health, and we can make it even stronger with the heavy research we have all over the Nordic countries in this region. So these are three typical examples where collaboration across the Nordic countries can make a huge difference. Anything to add?
No, except that considering the timing here, I think the way to amend this, if it is to be amended, is by way of you have a look. If you have specific changes you want to make, drop us a mail, and we will take both what has been said in the last quarter of an hour and any comments into consideration and do a redraft and circulate. Last page.
Yep.
The most operational one. And again, remember the very fragile mandate we have. But you will see here, and this is of course not put in here without Sofus being volunteering to undertake this role. But as there's been a lot of talks around the coffee and the buffet on how to bridge this arrangement, something ongoing, and his ministry has volunteered to take a first step of convening the other ministries and authorities together with the various stakeholders in developing a Nordic language model for a meeting to see how we can proceed with that. And in addition to that, of course, we have the informal rotation. Sweden will be hosting a similar meeting to the one we are just concluding on quantum computing, and we hope Finland will take over the following year, and we will inform about that further next year. So, specific drafting comments in writing, non-specific comments too late. So we are at the end of the session. We I think only need at this point to thank the organizers, both the University Center. Eva, where are you? You're right there, who has been the supreme organizer and herding in all the cats in the room, and then perhaps to thank each other for taking the trouble, for coming, for sharing, and for leaning into a very successful seminar. Thank you to our hosts, thank you everybody, and have a very nice weekend.
Yeah. Just to say, have a very nice weekend. On behalf of the rector who couldn't come, I will say thank you very much, all of you, for coming to the University of Oslo. It has been a pleasure for us to hosting this event, and it has been 2 interesting days, yesterday afternoon and today. So thank you very much, all of you, and have a nice trip home.